Savage Sullivan Math here. We are happy to have you join us again. Today we're looking at finding the distance between two particular points. So for this problem, we are looking to find the distance between the point -3, -1 and 4, 4. So the first thing I'm going to do is I'm going to plot these 2 points on my coordinate plane because I want to see exactly where they are. So remember, you have to go left or right to the elevator bay and then up or down however many floors. So I'm going to go left -3 and down 1. This is 1 point. And then I'm going to go right a +4 and then up 4. So I want to find the distance between these 2 points. So if I look at that, I'm just going to draw my line through these 2 points. That's not exactly an easy distance to calculate because it's not going nicely across these lines. It's going in a diagonal version. What have we done with a diagonal recently? We've worked with the Pythagorean Theorem. So we can do that here too. We can draw a right triangle on a coordinate plane. So I'm going to do that. I'm going to count how many I have to rise and how many I have to run. And that could be my different leg lengths. And then this red line, this distance, could represent my hypotenuse in the Pythagorean Theorem. So let's create our right triangle. So from this point, I'm going to travel right 1, 2, 3, 4, 5, 6, 7 spaces. So this is a length of 7. And then I'm going to go up 1, 2, 3, 4, 5. All right, if I look at this carefully, I can tell that this is my right angle right there, and I know directly across from the right angle is my hypotenuse, so I can see my right triangle, and I can plug that into the Pythagorean theorem of a squared plus b squared equals c squared. So a will be 7, b will be 5, and I don't know what my hypotenuse is yet, but I know 7 times 7 is 49, and I know 5 times 5 is 25. And then when I simplify the left-hand side of that equation, 49 plus 25 is a grand total of 74. This is not a reasonable answer yet. 74 would be way too long if my leg lengths were just 5 and 7. And as I look at that closely, I see that, oh, this isn't just c, it is c squared. So I need to take the square root of each side because remember, square roots and squares, those are inverse operations, so they cancel out. So my answer is going to be c is equal to the square root of 74. Perhaps the directions said round to the nearest tenth though. If you round to the nearest tenth, you would find that c would be approximately equal to 8 6/10. So there you have it. I found the distance between 2 points because I was able to create a right triangle and use the Pythagorean theorem.
What happens if I don't have a coordinate plane, but I still want to find the distance between 2 points? Well, we have something called the distance formula, and it looks terrifying. I know, this is what we call the distance formula. It looks scary, but when we really break this down, you actually have seen this before. What if I told you that the distance formula is really just Pythagorean theorem? Pretty crazy. So if we think about what Mrs. Sullivan just did on the coordinate plane, she counted the length between 2 points on her x-axis and counted the length between 2 points on the y-axis, and those numbers became her leg lengths for her right triangle. So really, when I think about what the distance formula is telling me, these right here, my 2x coordinates, I'm finding the distance between them. So this is one of my legs. Same thing on my y-axis. On my distance between my y coordinates would be my other leg. And why are they squared? Well, if we think about the Pythagorean theorem, a squared plus b squared. So if these are our legs, then ideally these are really a and b. Interesting. So why the square root? Well, instead of using c for the hypotenuse, we're using d now because we're saying distance. So imagine this is really c, your hypotenuse. So this is a, this is b, and now this is c. So a squared plus b squared would equal c squared, but if I just wanted c, I would have to take the square root of the entire thing. So we really are ending up now with what we call the distance formula. Sounds scary, looks scary, but I promise it's really just Pythagorean theorem. So what do we use this for? We use this for when we don't have a coordinate plane and I'm just given 2 points that I want to find the distance between. So for example, if I had written out directions here, my directions would say, find the difference between the point 3, -1 and -2, 5. I don't want to spend time drawing a coordinate plane and plotting the points and counting, so I have this distance formula that I'm going to use. So, as we remember, when we were finding slope, we can label these as x1, y1, x2, y2. And then it's really just plugging them into the correct spots. So the key to being careful here is making sure that you are not doing too many steps in one. So I'm just going to plug in what I know. x2 is -2. Again, you don't have to make that your x2. This could have been it, but you have to keep them the same. So -2 minus 3, x2 minus x1 squared, plus my y2 minus my y1, 5 minus, and do not lose that -1, squared. Like I said before, if I wanted to make this x1 or x2 and this x1, it would have been the same, 3 minus -2, but then this would have had to have been -1 minus 5. So just keeping that order consistent, just like we did with slope formula. Now we're going to simplify inside of those parentheses. So notice I'm copying everything down. -2 minus 3 is -5. We're going to keep that in parentheses, squared, plus 5 minus -1 is a +6 squared. So far, so good? Let's keep going. So now we're going to square what's inside of those parentheses. So the square root's coming along. -5 squared. -5 times -5 is a +25. Plus 6 squared, which is 36. Remember, it's 36, not 12. So then we add the 25 and the 36. So again, I'm going to bring down that square root. 25 plus 36 is 61. Phew, a lot of steps, but not too hard. We got there. So when you get here, it depends on what the directions are asking, but we have 2 options. We can always leave it as a radical and make sure that the radical is simplified completely. So when we look at radical 61, we do know that there are no perfect square factors that are going to go into that. So we're going to leave it like that. So this would be an acceptable answer. Or if the directions said to give it as a decimal, I could put this in my calculator and get the decimal. If I were to do that, this is approximately 7.81 if I were going to round it to the hundredths place. But typically, because in math we don't like to introduce rounding error, leaving it as a radical is going to be your best bet. Just make sure it's simplified. If you found this video helpful, please like and subscribe.